Yo. We're going to be, I'm going to teach you the formula to figure out the average rate of change of a function. I abbreviate it as Aroc, okay? Aroc for average rate of change. Here's the formula, and let me just show you the formula, and then we're actually going to work on a couple problems together so that you'll see how it works in action. Then you'll get a better idea, okay? It's f of b minus f of a all over b minus a. And in order to really understand this, I'm going to do a problem with you guys, all right? It's like, how fast does the y values change compared to how fast the x values change? Average rate of change is the same thing, all right? So if we're talking about a straight line, they're going to be equal to each other. But how do you calculate the slope of something like this? See, the thing is, the slope, you could take the slope of this line here. You can take what's called the tangent line. So if let's say this point here, it's a little bit easier. If you want to know the slope of the line at that point, you'd have to say, well, I can draw a tangent line here, and then I could figure out the slope of that line. But then you'd say, okay, what about over here? Well, if you draw another tangent line here, you get a different line. You get a different slope. So it depends on, like, every place you measure on a curved line like this, you're going to get a different slope. That's why they talk about the average rate of change. So let's say from here to here, if you just want to know what the average rate of change is, this is a way to sort of say, okay, well, I'm going to average all of these slopes together to give you like the roughly what the average would be, okay? This is when this Aroc thing is more important. For straight lines, it's really the same as just saying, well, what's the slope of the line? Because if you have a straight line, the slope from here to here is the same as the slope from here to here. The slope is the same anywhere. But you see, like a line like this, the slope changes, or the rate of change changes.
So
okay?
that's when we're going to be using rate of
Yeah,
change? Oh,
yeah.
okay.
I mean, and you could use it here too, but you'll see it ends up being the same as the slope, but that's okay. Let me give you an example. So I need to give you a function.
Wait,
Go ahead.
sorry.
What, no, sorry.
We're not trying to find the slope, though. We're trying to find the rate of change.
Yeah,
that's
but what I'm saying is for a straight line, they're the same thing.
Okay.
I just want to make sure that it doesn't look like this divided by that. It's the same thing for a straight line. Okay? So it's not as interesting if we're talking about a straight line, because you can just say, well, let me just figure out the slope. But for a curved line is where it's more useful, because you can't say what's the slope of this thing, because it has different slopes depending on what point you're talking about. Okay? So let me just give you a function, and we'll use this formula, and you'll see. Once you see it in action, it actually gets pretty easy. So we've got here f of x is equal to 5x plus 7. So the other thing with this is, you might say, what the heck is this a and b? Where am I getting the a and b from? Well, that would be like here, when I said if you want to find out what the average rate of change from this point to this point is, the smaller point, the value of x that's more to the left is your a, the bigger one is your b. That's where usually it gives it to you in the problem.
Oh, I
So,
know what you're talking about.
So in this problem, they actually tell you, figure out what the average rate of change is for this function over this interval. -2 is less than or equal to x, which is less than or equal to 3. So in other words, like if we were looking at the picture, this would be the -2 and this would be the 3. You're only looking at that one piece. Average rate of change, it's always like, you're never going to look over the whole function. You're going to say, okay, for this piece here, what would be the average rate of change for this piece? Or maybe this piece, or that piece. So they always have to give you like a left point and a right point. And a lot of times they give it to you as in this form, which is an interval. But this just means the x goes between -2 up to +3.
Oh yeah,
right?
same as the bottom as well. Because
Yes.
That would be b, then a.
So-
it would be b times a, right? And then
Hang on,
plus,
it's not times.
plus.
You'll see in a second. The smaller one is always going to be your a. The bigger one is your b. I actually write the a and the b so that I keep it more organized. Let me just, oh no, I can go right here. So we're going to use our formula here, average rate of change. We want to figure out the average rate of change of this function, f of 5x plus 7, over this interval, where the a is -2, the b is +3. So first of all, you just want to write the formula. F of b minus f of a all over b minus a. Now we're just going to replace, wherever you see the b, I'm going to replace it with a 3, and wherever I see an a, I'm going to replace it with a negative 2. So this is going to be f of 3 minus f of negative 2 all over 3 minus negative 2. Let me get some more space here. Let me rewrite this because I kind of jumped it, I smashed it all together. Let me just make it a little bit easier to see. So we have f of 3, right, because the b is 3, minus f of negative 2, because the a was negative 2, all over 3 minus negative 2. Everybody see how I did that?
Mm-hmm.
So the first step is to write the formula. The second step is to, know which one is A and which one is B and just replace them here. Okay? So we have to find out what f of 3 is. Our function was 5x plus 7, right? I mean, yeah, our function was 5x plus 7. So to figure out what, this is basically saying, what would the output be if the input was 3? In other words, if the x was 3. So what you're going to do is you're just going to replace the x with the 3 here. So you can say, all right, f of 3 is equal to 5 times 3 plus 7.
15.
15 plus 7 is what? Good. So f of 3 is equal to 22. So now for the next line here, I'm going to replace the f of 3 with the 22.
Oh, it is 15.
Okay? So what do you think? How do I find what f of negative 2 is? What do I do? Same thing. Except I replace the x with the negative 2 now. 5 times negative 2 plus 7. That's negative 10 plus 7, which is what? Negative 3. So now I can replace, well, first I have to put the minus in. I can replace the f of negative 2 with the minus 3. And 3 minus negative 2, that's the same as 3 plus 2. That's 5. Okay? What's 22 minus negative 3? Those two negatives in a row become a plus. So what's 22 plus 3?
25.
So you get 25 divided by 5. So the average rate of change between negative 2 and 3 is 5. Okay? So you got to get in the habit, though, each time, write the formula, write what A and B is, plug it in, and then you got to do a little bit of work on the top. The bottom is always easy because you're just doing whatever this is minus that, right? The numerator is where you got to plug it in to find out what the thing would be. Unless they give you a graph or a table, then it actually becomes easier, okay?
Yeah.
So that was just one example. Let's look at the sheet now. And actually, you'll see if you have a graph, it's actually a little bit easier than this. If they give you an equation, it's usually the one that's the most work, okay? Huh? Yeah. Can I erase this then? Well, all right. No, you need it. So this was just an example that I picked up from, actually this is from Algebra 2. This is from like after you pass the algebra regions. If you want to take more math, you'd go to take Algebra 2. So this is just like an example I used from that. All right, yeah, you know what? I want to bring up this sheet on the board. Actually, I think it'll make it easier. Look at that! I got there for these questions. All right. So guys, look at this sheet. Max and his younger sister Evie are having a race in the backyard. Max gives his sister a head start, and they run for 20 seconds. The distance they are along in the race in feet is given below, with Max's distance given by the function m of t, in other words, Max, and Evie's distance is given by the function e of t, for Evie, right? So the distance, the t represents how many seconds. So at any point, you can find out how far they are in the race, okay? So this is Max, and this is Evie, right? It says, how do you interpret the fact that m of 12 is equal to 30? Well, M of 12, you have to look on this line, because that's the max line, right? So 12 is going to be right here. Right? Each one of these lines is worth 2 seconds. 12, 14, 16, 18, 20. So we go up here, and that corresponds to the 30 here, okay, which is the distance.
Yeah.
So how would you, in English words, can you explain what that means?
Wait.
Explain what means that.
M of 12 equals 30. Like in terms of English words, what does that mean?
Max is 12, right? Nah, hold on, buddy.
It is max.
The distance. The distance.
Oh, they running.
Yep, they're running.
So 12. The distance of 12 seconds. No, the time of 12 seconds.
Right, the time is 12 seconds.
Given the distance of 30.
All right, so what does that mean in English? How would you say it in a sentence? Max.
It took max 12 seconds to travel 30 miles?
30 feet.
30 feet.
Yeah, if you could do 30 miles in,
I was trying to put it together in my head.
12 seconds, that would be pretty fast.
I was trying to put it together, but it sounded like y'all was just getting there. Like,
He was.
Yeah, that's what I'm saying.
Yeah.
I was like, he got it. Like,
Yeah, no, he did. So what this means is, after 12 seconds, Max has run 30 feet. That's what you're going to write here, okay? Or the way you said it was fine, too. You said it a little bit differently, but the way you said it was good. After 12 seconds, Max has run 30 feet. Okay? So this is where the time is equal to 0 and the distance is equal to 0.
Because I need to get a alcohol pack and a Band-Aid.
It says if both runners start at where the time is equal to 0, which is right here, how much of a head start does Max give his little sister? And how can you tell? So this is his sister and this is him.
yeah.
How much of a head start did he give her?
Wait, he gave her, wait. Don't even say it.
I'm not.
He gave her, excuse me, wait, I just want to, he gave her an 8-second head start?
Nope.
No?
They both start at the same time. There's another way to give somebody a head start other than letting them start before you. They both start at the same time.
He ran at a different pace.
No, well that's true too. But at what distance does Max start at?
Yo, wow, I was just thinking that. Oh my god, yo.
Wow, say it.
So
Say
they
it.
both started at different places.
Good.
She
So-
started before him.
How far ahead did she start?
She started at 25
started-
feet.
25 feet is right.
He started
Good.
at 0.
I was
So-
like, yo, she had to be standing like in front of him.
Yeah.
I was like, wow.
Well, there's two ways to give somebody a head start. One is to say, all right, I'll start running, but before I start running, you can run for like 3 seconds, and I won't run until after 3 seconds. So
Yeah.
they could get a head start with time,
Mhm.
or you could say, all right, I'll start here, you start up there,
Yeah.
and then we'll both start at the same time. That's giving so there's two different ways to give somebody a head start, right? So,
Yeah.
how much of a head start does Max give his little sister?
25.
25 feet.
Track runners be giving each other head starts.
You talking about when they're on the curve?
Yeah, because they don't be starting at the same, they
No,
don't be starting all
they
the
are
way
actually.
on the line. They be,
Yeah,
like,
it's a
one be right here. the
I know what you're
other
talking
one be
about.
right here, the other one be right
But
here.
that's only if they're going around the curve,
Yeah.
right? So like this guy starts here, and like this guy starts here.
Yeah.
All right, the reason is because they're not actually running the same distance.
Yeah, that's a
Because
fact.
this person here has to run farther,
Oh, yeah.
because you see how this is closer?
Yeah.
So to make it up, because he's running farther, they stagger it by a little bit so that they're really running the same distance. That's what it is. It works out, if you see at the end, usually when they come around, they're all together pretty much at the finish line,
All right, so when they run it straight, they all just line up.
Correct, yeah, if there was no curves, then there's no reason to do that. Like for a short distance, like 100 meters or something, they all start at the same place. But usually, if they're running, 300, 400 meters or something, they have to go partly around,
I
Yeah, I know what you're saying.
I've seen them do that a couple times. They do that in NASCAR too.
Yeah.
They do that in NASCAR.
Well, because they're going around the curve
Yeah,
too,
I
yeah.
think they just the last person was just
Yeah.
mad
Nah.
fast, so he just.
Right? Like the best place to be is over here.
Fast.
It's always better to be
Yeah,
here.
because you could just
because it's like slightly less distance, you know.
Yeah.
That's another reason why if you ever watch the NASCAR stuff, like they usually have like a big track like that.
Yeah, they don't like to be on the outskirts. Some cars don't
Right.
like to be on the outskirts.
But like if you're coming around here, right?
Like you're coming out around wide, and somebody just come around short.
Right. But it's
Or
better.
they
It's
just
better
speed
if
up.
you could stay closer, right?
Yeah.
And the other thing
Yeah.
is, like, if you're closer here, when you get here, you don't have to go. If you're over here, when you get here, it's like you gotta kind of go further out.
But it's the turning though.
Yeah.
Like, and NASCAR, you got how you turning on point.
Yeah.
That's
Oh,
when
yeah.
you crash.
There's also like, if you ever see some
That
races,
was-
they have a thing like, there's a curve like that, right? The shortest distance would be if you could make your car go like this, right?
Mhm.
And if you see, they try to do that, right? Because if you go over here, well, you're just wasting space. If there's a way you can like cut over there, right? You're always trying to shorten the distance, but
Yeah.
anyhow.
Mr.
All right.
Keegan, now use the bathroom.
Yes. All right. So he gave his sister a 25-foot head start. Does Max catch up to his sister?
No.
How can you tell?
Because she finished at 60 feet and he finished at 50. No.
He did. He finished at 50. You're right. But there's even an easier way to tell without even looking at the numbers.
Right. Kind of did.
Mm-mm. If he catches up to her, what would the graph look like? Those two lines, what would happen to the two lines?
Punch would have been me.
Yes. The lines would intersect. Because if the lines intersect, that means at the same time, they're in the same place.
Yeah.
In other words, they're right next to each other.
Mm-hmm.
That doesn't happen, right? He's catching up to her, but he doesn't have enough room. If they raced
Oh,
a
yeah,
little bit
so if the
further,
graph would have kept going, they would have.
right, so if they made it a longer race, he will catch her.
Oh yeah, those
Right.
two lines was going.
Yeah.
Or if he gave her a shorter head start, he'd probably catch her,
Right.
okay? But you can tell if he caught her, the two lines would intersect somewhere.
Yeah.
And since that doesn't happen, he doesn't catch up.
They're about to right now. If the graph was a bit bigger,
Well,
he would have probably caught up to at some point.
right, if you were to add even another 10 seconds, you know, if we were to extend this out, he probably will catch her, right? Somewhere in that range anyhow.
Yeah.
So, I mean, if you had a big enough piece of graph paper and rulers, we could actually figure out exactly when he would do it, okay? So does he catch up to his sister? No. How can you tell? Because the lines don't intersect,
Absolutely.
right? Absolutely, positively. All right, now the next one, actually Savion said already. How far does Max run during the 20-second race? He runs 15 feet. How far does Evie run?
35.
How'd you get 35?
Because she started at 25 and then 25, 25, 50, she 60.
Or you could say 60 minus the 25 she started. Yeah, she started ahead, right?
Right.
So you gotta say 60 minus 25 is 35 feet. We didn't have to do that with Max because he started at 0, right? So we didn't have to bother subtracting. All right, let me just scroll up a sec here. There's one more question down there, I think, right?
Yeah.
Oh, how fast do they both travel? Okay.
Mm-hmm.
Let me just write this. Max was, wait, actually I might be able to do this good. Okay. So Max had run 50 feet.
My son Pop. I ain't never heard about 4 reasons.
How many seconds did it take Max to run that 50 feet?
20.
So what's his speed?
20 seconds.
No, 2.5.
Good, 2.5.
Oh, 25. Okay.
Because because that's 50 divided by 20 is 2.5, and the units is feet per second.
Yeah.
Or you could put feet over second, or you could write feet per second, same thing, okay? Just like miles per hour, it's usually the distance on top and the time on the bottom, okay? So, somebody tell me what Evie's speed was then,
35.
huh?
16. Was it? No, it's 35.
Well, that's the distance, what's her speed? You gotta divide that,
60 divided by
not 60,
um,
35, because she started at 25, so it's gotta be 60 minus the 25 gives you 35.
yeah.
About 20 seconds.
35 divided by 20.
Is that 1.5?
5 or some shit, like 1 point something.
Yeah, 1.5.
You got calculators sitting in front of you, it's not 1.5.
1.75.
I think it's 1.75.
That's a fact.
I was showing Bob shirt kicking. Came in there.
Justin, did you put it in?
Yeah.
It's 1.75?
Yeah.
Okay. So Edie was running at 1.75 feet per second. Max was running at 2.5 feet per second. So who's going faster?
Max.
Yeah. Because, you know, the higher the number, the faster you go, right? If you go in 70 miles an hour, you're going faster than if you're going 55 miles an hour.
Right. Trying to catch up.
Sorry.
Hey,
Huh?
yeah. That's how you
I love them. Yeah. Why don't you give them some?
I was $10.
You can go home barefoot, right?
Yeah.
Can I erase this? You all got this?
Yeah, okay.
Khalil, you got this?
Yeah.
All right, let's go on. So notice we actually haven't, on this worksheet, we haven't done anything with rate of change yet. Because those were straight lines, and really, the speed ended up being the same as the slope. If we had just calculated their slopes, it would have been the same as the speed that we just got.
Yeah, we didn't have a graph, like with the rate of change.
Oh yeah, that Friday.
Oh, that's the rate of change graph?
Yeah, the one we were just looking
Oh,
at.
yeah. Now I'm talking about like the one with the swerve.
Oh, yeah, we haven't seen one, you're right, we haven't seen one of those yet, but we will. Or my name isn't Mr. Pessinger.
Oh, I thought you was about to say my name Bennett, and I ain't in it. I'm about to say really.
What's that?
I thought you was about to say my
Mr.
name
Pet
is
Singer
Bennett,
is
and
the
I-
homie?
And I ain't.
He's a homie?
Yeah, he's one of the homies.
I don't know, you mean, is he a friend, he's a good guy?
But a homie, like that's him, like that's
Mr.
him.
Livestock,
Like, he's cool.
Yeah, he's cool, yeah.
Do you chill with any of these teachers outside of like work?
Have you like one time like, hey yo, we out to go
Like,
see
probably like
some.
on a Friday,
Wow.
probably playing like, yo, this off.
Yeah, yeah.
No, sometimes we'll stay late here for a little bit. Here. It says, in the first exercise, we were calculating the rate that the function's y values were changing compared to the function's x values. So we were calculating how far they traveled versus how long it took them to get there, right? And they said, for that example, that was the average rate of change. It says, you should notice that finding the average rate of change is the same as finding the blank of a line. So what did we say earlier? For a straight line, the average rate of change is the same as finding the what?
The one.
What's the thing that measures how steep the line is? The slope. So that's what they're saying here, okay? Those problems that we just did, the average rate of change is the same as the slope because it's a straight line, okay? So this is where they just talk about, this is the formula, which I already gave you guys because I just wanted to get you a head start with that. So now we're actually going to do this problem here, okay? Consider the function given by f of x is equal to x squared plus 3. So here's your function. It says find its average rate of change from x equals -1 to x equals +3. So which one is A and which one is B from the two numbers they gave you?
X equal 3 is B, and F is negative. I mean, X -1 is A.
Good. This is your A. This is your B. Guys, right? The first thing you got to do is the smaller x is your A, the bigger x is your B. So we want to find the average rate of this function. So you're going to say Aroc equals f of B minus f of A all over B minus A. Now, wherever you see a B, you're going to put 3. what's f of 3? And wherever you see an a, you're going to put minus 1. Minus f of negative 1. All over 3 minus negative 1. Before I go on, does everybody see how I got to this place?
Yeah.
No.
First thing to do is they're saying, what's the average rate of change of this function from x equals negative 1 to x equals 3? Those are those two parts we're looking at. Remember I said, like if you're looking at something, you have to tell them what piece are we looking at, right? The smaller x is your a, the bigger one is your b. In this case, the a is the negative 1 and the b is the positive 3. The smaller one is your a, the bigger one is your b, okay? B for big. So all I did here was I just, in the formula, I replaced wherever I saw a b, I put a 3 in there. Wherever there was an a, I put a negative 1 in.
Did you put b plus a down there or b minus a?
B minus. It's just sometimes the negative, I just have to draw over it. Sorry about that. So, what would f of 3 be? How can we figure out what f of 3 would be?
Class.
Has something to do with this.
You plug it in.
Plug it in.
To the X.
Right. So, this would be f of 3 would be 3 squared plus 3.
12.
Maybe 12. Good. So I replace the f of 3 here with 12. What would f of negative 1 be? You gotta do the same thing.
No.
What's negative 1 squared?
Like 2.
No. What's negative 1 times negative 1?
Positive.
Positive 1. What's 1 plus 3?
4.
So 4. So we replace the f of negative 1 with the 4.
So 8.
And this, the two negatives become a positive. So this is 3 plus 1, that's 4.
8 over 4 is 2.
It's going to be 8 over 4, which reduces to 2. Your average rate of change of this function between negative 1 and positive 3 is 2. All right? Every problem is like this. It's just you got to get the function, you write the formula, you replace the a and the b, and then usually on the top you have to do a little bit of work to find out what the numbers are. Okay? But then you just plug it in, and then you just get simple math.
Wait,
It is easier.
How you got that bottom 4 again?
Because the two negatives in a row become, it's the same as
That
plus
changes
1.
that one to that
If you put in the calculator 3 minus negative 1, you get 4.
Ah.
But whenever I see two of them like that together, I just make that's a 3 plus 1, which is 4.
Because it's a minus sign.
It's,
And
the two negatives in a row
It's
become
a
a positive.
positive?
Yeah. All right? Let's
wait,
do
that
the
was
next one.
negative 3?
No, it was positive 3.
Oh, okay.
Right?
No,
Here.
two negatives in a row.
The next one actually is going to be even easier. Watch. The next one, instead of an equation, they're going to give us a table, and that just makes it a little bit easier because you don't have to do as much math, believe it or not. The function h of x is given in the table below. Which of the following gives its average rate of change over the interval 2 is less than or equal to x, which is less than or equal to 6? So which one is A and which one is B? For this thing. Which one is A and which one's B?
2 is A
2
and
is
6 is B.
Good. All right, so we're going to say we want to do this formula, right? F of B minus F of A
Negative 3 over 2.
all over B minus A. Actually, you could write H, because that's what they're using here, H, but that's okay. Well, it's the same thing. So now, what's A? The A, wherever I see the A, I'm going to put the 2, and wherever I see the B, I'm going to put the 6, right? So we have F of 6 minus F of 2 all over 6 minus 2. Minus 2. Now, since they didn't give us an equation here, we have to find out what F of 6 is from the table. If the input is 6, what's the output? Or if the X is 6, what's the output?
2.
Nope.
It says F of 6 is output.
If the input is 6,
Oh, yeah, it's 3.
right? So F of 6 is equal to 3. So you replace that with the 3. What's F of 2?
No.
What's 6 take away 2? And 3 take away 9 is negative 6. And that reduces to negative 3 over 2. Or you could write it as negative 1.5, same thing. You could leave it as negative 3 over 2.
In that same space, or you just have no space?
Yeah, I just, because I wanted to write it big enough so you guys could see it, because they can see on the video. But it's all supposed to be up there. You know, you could write it down here or something like that.
I just would
Or just write smaller than me. I write big because, you know, I have such a big brain that. So what was the answer here?
-3/4.
Yeah, that's what
Okay.
Oh, it's 1.
All right, one more here. Francis is selling glasses of lemonade. The function g of t, g is for glasses, I guess, is equal to t squared plus 4 divided by 2. That shows you how many glasses she sold after t hours. What's the average rate at which he is selling lemonade between t is equal to 2 and t is equal to 6? So again, we have the a and the b, right? And we're going to say Aroc equals f of b minus f of a all over b minus a. And really, you should be using g, but whatever, it's okay. So in this case, the b is the 6, right? So we're going to get f of 6 minus f of 2 all over 6 minus 2. How do we find what f of 6 would be? What's f of 6 equal to? Let me erase that part.
You gotta plug it into that.
Yeah, good. Plug it into that equation. So what's 6 squared?
36.
Okay, and you have 36 plus 4.
39.
Say again?
I mean, 40.
40. And what's 40 divided by 2?
What is it, 20.
20. Right? So you're gonna say, I'm just gonna write it here. You guys can write it out. F of 6 is equal to 20. So I'll replace the f of 6 with the 20. What is f of 2 equal to? So in other words, you got to put a 2 in there. What's 2 squared? 4 plus 4? 8 divided by 2 is 4. So you get 20, take away 4, all over 2, which is 16 divided by 2, which is equal to 8. So you see, it's the same formula each time, right? You just got to figure out what's my A, what's my B. And you know, if you have the table, it actually makes it easier because notice, all you got to do is read the number off, right? It was a lot easier than if you had to do the math here, okay? Any questions about average rate of change? All right, let me give you the homework.
I did that.
Good, then you don't have to do it. I know. I know that you know.
So